there, and thank you so much for joining me for this video. So this video is going to continue our series talking about the between subjects one-way ANOVA. And just like my previous video, I'm going to show you all how to do a between subjects one-way ANOVA analysis with post-hoc tests. Okay, and this time we are going to do the practice problem, whereas my last video was the first example that we went through. So this is for the practice problem. Okay, so let's go ahead and reorient ourselves with the practice problem. So basically the research question was, do you think that the way that you dress can affect your behavior or performance? So essentially we have, again, one categorical variable with 3 levels. So we have individuals who wore a doctor's coat, individuals who wore a painter's coat, and individuals who didn't wear anything. Instead, they simply saw a doctor's coat. So that was, the control condition essentially. Okay, so that's our independent variable. It's defined conceptually as clothing, and our levels are doctor's coat, painter's coat, or simply seeing a doctor's coat. Okay, and then our continuous dependent variable is performance on a visual search task. Okay, so those are our variables. So I'm gonna go ahead and share my screen so you guys all know how this works. Okay, so I'm again at the opening screen of SPSS. I just clicked on SPSS. Again, I'm going to choose new data set and double click. Okay, and that takes us to a brand new fresh SPSS sheet. Okay, but like before, we are in data view, and the first screen that we need to access is variable view. Okay, so I'm just going to click variable view. I'm going to put my cursor right there next to the 1. Okay, and just like before, I'm going to start with our continuous dependent variable, which is visual search task. Okay, so I'm just going to type that in verbatim, and I'm going to do the underscore thing because SPSS doesn't like spaces. Okay, so our name of our dependent variable is visual search task. I could do a label here, but again, it would be kind of redundant, right? So I'll leave that blank. We want to make sure that our measure is scale, okay? And that under type it says numeric, okay? All right, so we're good with our dependent variable. Now we need to type in our categorical independent variable, okay? So our categorical independent variable is, I'm just going to put dress here, type of dress. And then this is where the label will be helpful. So here I will put what coat was worn / seen, and that will remind us what our variable is, right? Visual search task is fairly self-explanatory, but maybe some more explanation would be helpful here. That's just for our benefit, though. It's basically like a notes column is what we have for the label column, or the label space. Okay, so now we need to make sure that under measure we select nominal, because again, all that we have, right, for this variable, it's categorical, so all that we have are names of levels, essentially. Those don't have any sort of quantitative or ordinal specification, okay? So they're the least precise level of measurement. All that they tell us is a name, essentially, okay? So we know that's nominal. And now we're going to have to start the process of dummy coding, right? So everything that's entered into SPSS has to be numeric, right? So what do we do for non-numeric variables, right? In that case, we are going to give arbitrary numbers that will serve as placeholders for our level names, okay? And that's the process of dummy coding. So what we're going to do is we're going to click on the values, and then we're going to click on the ellipses, and that will open up the box for us. Okay, and we'll just use the same arbitrary numbers, 1, 2, 3. Those are easiest, but it does not matter what number we select. We could select 99, 67, and 4018. Okay, so the number itself has no bearing. It could be any sort of number that we wanted. We just need some kind of placeholder for our levels. Okay, but let's go ahead and enter one as doctor's coat. Okay. 2 as painter's coat. Okay. And 3 as saw doctor's coat. All right, we click add, and then we're done. We click OK. Now SPSS knows what each level of our independent variable is, and they also have all the info they need for our dependent variable. Okay? All right, so now we're ready to go into data view and start inputting our data. Okay, so all right, so I'm gonna look at the PowerPoint. So we have our first variable is wore doctor's coat. Okay, so those numbers are 4354. Okay, 4354. And we're gonna tell SPSS that that is wore a doctor's coat level. Okay. Next we have wore painter's coat. That's 3122. So 3122. And we tell SPSS that that's the painter's coat level, which corresponds to number 2. Okay. And then we have our last group, our last level, which is saw doctor's coat. Okay, and those values are 3241. So 3241 in our visual search task column. And then we're going to tell SPSS that was group number 3. They saw a doctor's coat. Okay, so our data entry is complete, and now we are ready to conduct our analysis. Okay, so we're going to go to the Analyze menu. We're going to select Compare Means. Okay, we're going to select One-Way ANOVA. Okay, we're going to tell SPSS first what our dependent variable is, okay, which is Visual Search Task. So we're going to pop that into the dependent list. And then we're going to tell SPSS what our categorical independent variable is, which is what coat was worn, right? And so we're going to pop that into the factor box. Okay, but we still have some more information that we want, right? So we want to click on options so we can get that nice descriptive information, because remember, for our APA write-up, we're going to need the mean and standard deviation of our groups, right? Okay, so we'll click on descriptives, check that box, and then hit continue. And then we'll go up here to post hoc. And remember, we don't want LSD, we don't want Bonferroni, instead we want the Tukey. Okay, and then we're going to specify the alpha level for our post hoc test, which we always keep at 0.05. Okay, again, we're going to hit continue, and then we're going to hit OK. All right, and we have our output. Okay, So we have our descriptives, which again are going to tell us the values of the mean in each of our 3 levels. Okay, so right away we see that people who wore a doctor's coat performed the best on the visual search task. Their mean was 4, as compared to people that wore a painter's coat. Their score was 2. Okay, so half of the score of the doctor's coat. And the people that saw the doctor's coat did a little better, okay, but probably not significantly better, right? So again, we're only seeing a significant difference between people that wore a doctor's coat and people that wore a painter's coat, as we'll see with our post hoc test in a minute, okay? Then we have our ANOVA table, and we can check our work, right? So we have our nice F table that we calculated by hand. We've got our between groups. Sum of squares is 8.67. Our within group sum of squares is 9, which means obviously our total sum of squares must be 17.67. Okay, so that checks out. Similarly, we've got our between groups degrees of freedom, right, which is k minus 1. We have 3 groups, so that's 2. We have our within groups degrees of freedom, which is n minus k, which is going to give us 12 minus 3, our 3 levels, which is 9. Okay, and then we have our total degrees of freedom, which is n minus 1, just like with the t-test, right? And we know that our mean square for between and within is 4.33 and 1, making our F value 4.33. And we know that our ANOVA has at least one significant difference because our p-value is 0.04. Okay? Then if we go to the multiple comparisons, like I said, you'll see that the only significant p-value here, or because the p-value is denoted by the significance column. So the only significant p-value here, or the one that's less than 0.05, is for the comparison between the visual search task performance in those who wore a doctor's coat and those that wore a painter's coat. So we see that significance is 0.047. Okay, and again, if we look at the same exact thing, comparing painter's coat and doctor's coat, we see the same significance, okay, but none of the other pairs are significant, okay? All right, so that concludes our SPSS procedure for running a one-way ANOVA. I hope you guys have a great day, and I'll see you in my next video. Take care.